Alright, this is number 50, and what this is, this is an Atwood machine. And an Atwood machine is really just two masses hooked over a pulley. Okay, so this is where M2 is going to be bigger, 7 kilograms, and M1 is smaller at 2 kilograms. And instead of being released at rest, because if this was released at rest, the whole system would just go in this direction, right? M2G is going to be bigger than M1G, so the acceleration would be in this direction. However, you're told that this system, it started out with some initial velocity of 2.4 meters per second in this direction. So M1 is going down and M2 is going up. And so what's going to happen is this system is going to then come to a stop. It's going to come to a stop because, well, what did we just say? The net force is going to cause some acceleration in that direction. So if you think of the system as a whole, M2G minus M1G, that difference in their weight is going to cause an acceleration. Again, the acceleration is in that direction, and that causes M12 plus M1 plus M2 to cause some acceleration. And so the acceleration, if you look at this, is really the difference between their masses times some g. That ends up being 5/9 g. Okay? So what is that going to do? Well, now we look at the v squared equation. Again, the v squared equation relates us to a distance rather than a time. So our final velocity is going to be 0. We're thrown down initially at 2.4. This acceleration is in the opposite direction of the velocity. It's 5/9 g. And how long is it going to take? And you figure out that that x value is 0.529. So what this is saying is that this will go down 5.29 meters, come to a stop, and then it will accelerate the other direction. Well, now we want to figure out a different question. It says, what's the velocity after 1.8 seconds? Okay, so think of our standard velocity equation. Our final velocity, if we start out at 2.4, but our acceleration rate is negative because it's in the opposite direction, 5/9 g, for 1.8 seconds. And you get a value of 7.4 meters per second, and that's up. When I say up, I mean it's up for M1 and down for M2, right? The velocity of our whole system at that point is going in this direction.